Yes, ma'am.
Okay, so today we'll be talking about operators and expressions in Python. So we've seen some of the operators actually. We've seen the plus, the star, which is multiplication, and we've seen how it works with numbers and how it works with strings as well. But they are actually categorized separately. Like there are different ways that you use this arithmetic, the operators, not arithmetic, the operators generally. So in Python, we um use operators to perform calculations, make comparisons, or create logical conditions, or to check if there are some correlations between like logical expressions from a particular expression to another one. Just basically that's it. So there are special symbols that perform operations on variables and values. So we already know what variables are and we know what values are. Values are what is contained inside the variables. Okay. So now
Yes, continue.
we have different types of operators. Let me say they are categorized differently. We have arithmetic operators, most of which we are already familiar with. We have assignment operators, which is something similar to how you create variables and how you work with variables. That's what assignment operators are. You see that, yeah, in this box. And then we have
Yeah, I can see.
comparison operators, which are what you use to compare two values to see, and they usually return like Boolean values, true or false. The way I'm saying is 5 equals to 3. So it's definitely 5 is not equals to 3. So that will return something like a false value. So those are comparison operators. We have logical operators. Those are and, or, and not. We'll talk about them in more details. And then we'll talk about other operations. There are more categories for these operators, and you can find them in that link that I shared in the first notebook in W3 school. So,
Yeah.
but we'll just be talking about arithmetic operators, assignment operators, comparison operators, and logical operators for the purpose of this class. Okay, so let's start with arithmetic operators. So with arithmetic
Okay.
operators, hello, did you say something?
No, I'm listening, ma'am.
Okay, cool.
Mhm.
So what arithmetic operators are is they allow you perform some calculations in like some mathematical calculations. Let me just put it that way, that we are already familiar with, like addition, subtraction, multiplication, division, floor division, modulus, and exponentiation. Those are the major um arithmetic operators that we have in Python. So addition, we already know what addition does. You add something to
Yeah.
something, it gives you a
Yes, ma'am.
particular result. And this is the sign you use in Python. For subtraction, okay, let me zoom in so we see that clearly. For subtraction, we have the minus sign that allows you to subtract a particular value from another value. Then we have the multiplication. The multiplication sign is written as this star, and then you use it to multiply something. We are familiar with that already. So for division, we use the slash. We are using forward slash. So we
Yeah.
use it for this.
Okay.
And usually whenever you have
Division.
like a division, if you check the type of the result of your division, it will be a type float, because even if it's like whole number, if you do like 6 divided by 2 and it's supposed to be 3, but to give you 3.0, because whenever you use this division sign, you always get um a floating
Decimal.
point number. Yeah, a decimal
Yeah.
number. So when you check the type, you're going to get a float, because even if it is whole number, to write it as 3.0. So unless you now want it as an integer, you can convert to integer using those
Integer.
the int function. Yeah. So then we have floor division. What floor division does is like it will give you like just like if you do the 7 divided by 2, it's supposed to be 3 remaining 1, right? But it's just going to give you
Yes,
just
ma'am.
the 3. It will drop the decimal place. And the reason it is floor is because if like this one now is supposed to be 3.5. You know, when you want to have that kind of thing, you're supposed to, and it's rounding up, it's supposed to give you like 4. But because this is floor, that means it's going down, not up. You're rounding down, not rounding up. So the result of that is usually an integer, and it's just the number without the remainder, irrespective of whether the remainder is something that should round it up or down. So that is what floor division does. Then we have modulus. Modulus is just the remainder. Like when you do 7 modulo 2, you know the result of 7 divided by 2 is supposed to be 3 remaining 1. So it's the remainder that is going
One.
to give you, in this case, which is 1. 7, 3 remaining 1. If you do 5 modulo 3, what should that give you? It, what's will 5 modulo 3 give you in that case? Can you guess based on what I just said now?
Hello?
Hello, are you there?
Yes, for me too.
Okay, I said 7 modulo 2 will give you 7 divided by 3, 2 will give you 3 remaining 1,
You remain
right?
that one.
So
Yeah.
that means
Yes,
7
ma'am.
modulo 2 will give you 1. Now, if you do 5 modulo 3, what would your result be?
5 divided by 3. That is 3 remainder 2, ma'am.
And so for modulo, when you are using modulo, this percent sign, remember that it's just this remainder that is going to give you. So what will be the result of that now?
Okay. But in flood division, it will give us the. It's not going to. It's not going to give us the remainder. It will give
Yeah,
us the actual. Yes.
yeah, but I'm not talking
But
about
in.
modulo.
Okay.
Mm-hmm.
7 modulo 2 will give us 3 remainder 1.
Now, let me explain that again. There's something you're not getting. Now, flood division is this double forward slash, right? And to give you the exact number without the remainder, the exact
Okay.
division, yeah, without the remainder. Now, for modulo, this percent sign is not just percent, it's not talking about percent. It's like you're doing
Fine.
7 divided by 2. But instead of giving 7 divided by 2 is 3 remaining 1. So you forget about what you divide it by, like that 3. You forget about it. Is that
Okay.
remainder, that 1 that remains, that you'll be getting when you use modulo. So that's what is happening here. You did 7 modulo 2 and the result is 1. Do you get it?
Yes, ma'am.
Okay, so when I do say 5 modulo 3, what would be the result now?
3 remainder 2.
Forget about the 3.
Okay. That will be 2, ma'am.
2, exactly. And it's not even 3
Yeah.
remainder, it's 1 remainder 2. 5 divided by 3 is 1 remainder 2.
1 remainder 2.
Exactly. So you forget about the 1. Is that remainder that you are getting whenever that you get as output whenever you do modulo? Do you get it now?
Yes, ma'am.
Okay. And then exponentiation is just like
Sure.
you saying something raised to power something. So 3 raised to power 2, that means 3 square 2, abi. And if you say 3 times 3 exponentiation 3, so that means you're saying 3 raised to the power of 3, which is 27. Do you get it? So that's just how all of this works. So you have addition, subtraction, multiplication, division, floor division,
For
modulo
division.
exponentiation. So let's see some examples here. So when we run this, you see A is equals to 10, B is equals to 3. Definitely when you do A plus B, you have 13. A minus B, you have 7. 10 times 3, 30. Then division, you see how the division gave you like that extra thing, extra value here. Then you have floor division. Floor division, 10 floor division 3 will give you 3 without any, it's not going to show you what the remainder is. Now, what is 10 modulo 3? Let me ask, you know, 10 modulo 3 is what?
And 3. That will give us 3.3. But we are going to use the just the remainder. That
Mm-hmm.
is 3.33333.
No. Remember when we said 7 modulo 2 is 1, right? 7 divided by 2 is 3 remaining 1.
Remainder 1.
Abi?
Yes,
Yeah.
ma'am.
So now when you say 10 divided by 3, what is that?
It will give us 3.3333.
Forget about that 0.33. When you do normal division, you are counting now. You do, let's say, remember when we started learning division, right? We'll say three, you count up to 10, you divide by 3, right? You split into threes. Then what will be the remaining thing that is left?
1.
Exactly. So that will be 3 remaining 1. Is when you convert the 1 to decimal that you get 0.333, but we are not converting to
3.
decimal. It's just that remainder that we are talking about. Do you get it now?
Yes, ma'am.
So 10 modulo 3 is 1. Let me ask another one. Okay, so 15 modulo 6 is going to give you what?
2.
Is that 2? Think again.
It's 2. 16. It's
Huh?
16 modulo. 15 modulo 6
Yes.
is 2.
15 divided by 6 will give you what?
2.5.
See, you'll be confused if you are using point something. Yeah. Now 15 divided by 6 will give you 2 remaining what?
5.
Is it 5?
Oh. Yeah, it's 2 remaining 5.
6 times 2 is what?
6 times 2. 6 times 2 is 12.
15 minus 12 is what?
3.
So what's your answer?
2 remaining 3.
2 remaining 3. Yeah, so what's 15 modulo 6 now?
3.
Okay, thank you. Do you get it now? Or is still
I'm getting
confusing?
it.
Eh?
I'm getting it.
You are
I'm
getting
getting
it.
it.
Yeah, let me give you another one.
Yes.
20 modulo 9 is what?
2.
Thank you. You are getting it. All right. Another one. 24 modulo 7 is what?
4.
Is it 4? 24 modulo 7.
Yeah, it's 4. 3. It's 4. 24. What would be different? Alpha.
24 divided by 7 will give you what?
3. It will give us 3.4285.
Forget about the
Like,
point.
yeah.
Forget about the point. The point is what is confusing you. If you do normal, our initial this thing, 24 divided by 7 is going to give you 3 remaining something.
Remaining 3 remaining 4.
It's not 3 remaining 4. So yeah, 7 times 3 is what?
20, it will give us 21.
Okay, so the remaining thing between 21 and 24 is what?
3.
Uh-huh. Is
It's
that
3 more.
decimal that you are using that is confusing you? So it's 3 remaining 3.
3.
Yes, so 24 modulo 7 is
Hello.
3. Yeah, hello. So we have assignment operators too, where you we know how to assign something, right, to a variable. Like you do x equals to 10, so we understand that. So we understand that the equals to this one, this single equals to sign is used to assign a particular value to a variable. So that's just what the equals to is. We understand this one. Now, there are other variations of the assignment operator of this. Let's assume that you have a variable like x is equals to 5, for instance. And you decide that, okay, you want to add 3 to 5. An example of it is, let's assume that you're going to the market, okay? And then you you initially thought you wanted to buy 5 eggs, and then at the end of the day, you already have a variable for it, or you already in the market and you already have like a container that you place the egg in, 5 eggs. Then at the end of the day, you decide that you want to add 3 more eggs to that same container, right? You want to add 3 more eggs to that same container. Now, instead of just taking the container and adding it to a different container again, it will take a long process. So there's a way in which you can, a short form of it, where you can just add the new number of eggs that you want to add to the container straight up, and that's it. So it's just like saying, this is my initial variable x. Now to the initial x, I want to assign x plus, sorry, you want to do x plus 3. You already have 5 eggs, right? Now you want to add 3 more eggs to that x, and then we assign it back to that same container x, such that initially when you print x, I think we did something like this before, print x to give you 5. But now when you print x after doing the addition, you would have 8. Initially, before you added 3 to x, you had 5. But now that you have added 3 to x, and then we assigned it back to x, and you're printing x again, you have 8. Do you get it? So that's just how this works. So I'm just going to do this, and now, instead of writing it this way, there's a shorthand for it, since we are using the same container. It's the same hex. So instead of writing it this way, long form like this, what you can just do is do something like x plus equals to 4. So now x should be, 8 plus 4 should be 12. So now x will be 12 if you write that again. So that's just how it works. So instead of saying x equals to x plus 4 again, what you can just do is use this shorthand, x plus equals to 4. So that means you are adding 4 to the initial x without having to reassign the way we did here. So this is all this short form of this. Do you get it? So if I run this, I would have 12 next, and that's it. Do you get it? Are you with me?
I get it. Yes, ma'am.
Okay. So same thing if you want to subtract, what you just do is do x minus equals some, whatever it is you want to subtract. X minus equals 2. And then we print x again. So just you're reassigning and doing some calculations at the same time. And then you have 10. So the same thing with multiplication. You can do multiplication equals, you can do division equals, you can do modulo equals, something like that. You can do all of those things with those assignment operators. It's just you reassigning variables while also performing an operation. Okay, are we good? Are we okay? Okay, cool. So then we have comparison operators. Now, when you want to check if something is equals to something, remember that this equals to, this single equals to is an assignment operator. You are using it to assign a value to a variable. But when you want to check if something is equals to something so that it will return true or false, you use double equals to, such that if I have x equals to 10 and x equals to 7, and I want to check if x is equals to y, so I will say x equals y. So it should return true or false. So this is definitely false because x is not equals to y. So it's going to return false. Now, if I want to check is x not equals to 4, I'll use this exclamation mark equals to. You see this exclamation mark equals to say is not equals to. So if I definitely this will return true because x is not equals to y. So if I do s exclamation equals y, that's saying I want to see if x is not equals to y, such that if I run this, it returns true. Then we have greater than. If I want to check if x is greater than y, so since x is greater than y, we get true. We can do x less than y, x greater than or equals to y. We know what all those say. Or x. Those are the comparison operators that we have. We are familiar with them. We want to check if something is equals to something, is not equals to, greater than, less than, greater than or equals to, less than or equals to. So if we run this, we see everything as it should be. So x is not equals to y. That's false. True, false like that. Okay, so the last set is logical operators. So when we have three operators there. If you're familiar with logic or logic gates or something, you'll understand this very quickly. So we have three operators here. We have and, or, and not. So and, the way and works is whenever you're comparing two, combining two multiple conditions, both conditions has to be true before it returns true. Do you get it? Both conditions, if it returns true if both conditions are true. Like let's take for instance, you check 5 greater than 3. Then you have 8 greater than 5. So now 5 is greater than 3. That's true. 8 is greater than 5. That's true. So if you combine that true and truth, definitely you get true. Do you get it now? Then if you have, but if you have something like 5 is less than 3, definitely 5 is greater than 3. So that would become false. And then you have this one that is still true. If you do false and true, it's going to return false because one of the conditions is actually false. It's just like saying, let me just have something up here. You can consider and as multiplication and or as plus. So it's just like saying you say true. This is just the trick to it. True and true will return true. If you have true and false, it will return false. It's just like doing multiplication with ones and zero. Remember I said one is true is one and false is 0. So if you do 1 times 0, definitely it's going to give you 0. So that's why you're getting false. So if this condition is true and the other condition is false, definitely one of it has spots, it's one egg spots the other one. So it's just going to return false straight up. So this is like saying 1 times 0. So you can consider and as something like you're saying multiplication of booleans. Let me put it that way. Multiplication of booleans. So definitely when one of it is false, it's going to return false. Even if you have 3 separate expressions that is returning and 2 is returning true and one of it is returning 0, definitely 1 times 0 is giving you 0. So 0 times 1 is still going to give you 0. So one of it has put the rest of it. So it's going to give you, although that's not the right word, I'm just using that to explain what is happening here. So definitely it's going to give you false. So that's in the case of and. Now, when we are talking about or, just one of the condition, at least one of the condition, if one of the condition is true, then it's going to give you true. You can consider or as something like addition. You know, when you say 1 plus 0, it's still going to give you 1. So we are still good. Do you get it? If you do 1 plus 0 plus 0 or 1 plus 0 plus 1, it's still going to give you 1. Do you get it? Because you're still in the same line. That's in terms of logic. So you're still good. So for and, you can consider it as something like multiplication, where if both conditions are true, definitely return true. But as long if one of it is now false, everything will return false. And for all, just one of the condition has to be true. So if one of it is true and the other one is false, you still get true. That's just how all works. And not is just like reversing the result. If you have true before, if you use not, it's just going to negate it, just like that. So let's look at this example that we have here. If I run this, we have A equals to 5 and B equals to 10. So we want to say A less than B. A less than B is true, and B less than 20 is also true. So true and true will return true. Now A greater than B is false. B equals to 10 is true. So we are saying true or true. Since we are saying true or true, that's true. One of it is actually true. Then we have A equals to 5. Then that's true. A is equals to 5. Well, because we used not, it negated the true to false. That's just how the what's it called, logical operators work. Do we get that? Are we good? Are we good?
Uh, Yeah, yes, ma'am.
Okay, cool. So we have order of operations for all of this. We should be familiar with board mass. It's just similar to it. This one is PEMDAS. They just call it PEMDAS here. So where you have to evaluate whatever is inside the parentheses first, then followed by exponents, then followed by multiplication, division, floor division, and modulus, then followed by anything that is addition and subtraction. So it's just based off of our knowledge of board mass in that case. So that's just it. So we have some exercises here that you can try out. We have some we have 3 exercises that you can try out against next week because today is the last class for this week. Yeah. So we'll continue with whatever it is we have again next week. With these exercises next week. So do you have any questions so far on operators?
The question that I have is still on the, I don't know what they did. This on this floor division on arithmetic operators.
Okay, what about it?
That's the issue that I have. I don't know. I'm not getting it.
Okay,
I'm
so
trying to.
you remember what modulo is? You understand that modulo now?
Yes.
Okay. So floor division is like you are dividing 7 by 2. Let's start with that. You say you got 3.5, right? Or you can say 3 with that one. So with that, you are forgetting about what the remainder is. You are only focusing on what the division is actually giving you, which is 3. So the same thing, if you do 10 floor division, um, floor division 4, for instance, you are going to get remaining 2, right? But because
Yes.
we're what? What did you say?
Yeah, I'm getting it now. Two
Okay,
remaining two. Yes.
so 2 remaining 2. But we do not care about the remainder. We are caring about the actual division, forgetting about the remainder, which is 2. Do you get it?
Yes.
Yeah. So, and you know
But
that, but what?
but in modulus, like we are going to care about the remainder. Is the remainder we care about in
Yeah, just the
modulus?
remainder. We are getting the remainder only. We are focusing on just the remainder only. Do you get? So like how I said 10,
Yes.
10 divided by 4 now, and I said it's 2 remaining 2. If I'm doing 10 modulo 4, the result of that will be 2. That's the remainder. Do you get it?
Yes.
Yeah, so that's just it. Are we
Alright.
together?
Yeah, I'm with him.
Okay, cool. So that's just it. All right. So I think I did not send the last notebook to you. So let me send it to the group right now so that you can open it.
Download.
Okay. Collections in Python. So basically, we have four collections in Python, and they are used to store multiple items in a single variable. Okay, they help us group, organize, and manage those related data easily. So what this is talking about is, we have what we've been doing so far with variables is we just put a single value. Like we say Zainab is equals to name, name is equals to Zainab. So that means we are assigning Zainab to name. So what if I have a list of names? Like I have a lot of names. I have Zainab, Mustafa, Rashid. I have a list of all of those names, and I want them in just a single variable, just to categorize them together. Then I would need something that will collect everything together before assigning it to that particular variable. That is just what we'll be discussing in the next few minutes. So we have four types. We have um list, the main ones: list, tuples, sets, and dictionaries. Those are the four ones that we'll be talking about here. So lists are ordered, changeable, and allows duplicates. Now, what that means is items in a list, they come in a specific order such that you'll be able to access the position of each one, like the way we would access, index. Remember index? That was why I said you should pay attention to indexing and slicing when we were doing it earlier, when we were talking about strings. So you'll be able to access the position of each item inside that particular list. That's why it's called for that. Then changeable. Each item in that list, you can easily change them. You can replace them with something, or you can just remove them with something else. You can do that. And then it allows duplicates. That means you can have the same item inside that list multiple times and you have no issue. Okay? While tuples, they are ordered just like this. You can access the position of each one and you can do indexing and slicing with them. And then, but the only thing is you cannot change whatever is inside a particular tuple. We'll talk more about each one. I just want you to see the comparison between each of those collection types. So then it also allows duplicates. But with sets, they are unordered. They do not come in a specific order. You can see them like maybe they are writing them in a particular order, but they are actually unordered because you cannot do indexing and slicing with them. You cannot say you want to access a particular position of a particular item inside the set. And they do not allow duplicates. So that means they contain unique values. You cannot have two apples inside a set. You cannot have two bananas inside a set. It's just a single one. So it contains just unique values. And they are unchangeable. That means you cannot change the values inside a set. If you have apple there, you have apple here. But if you want to change it, you have to convert it to a different data type, collection type that allows you to change it. Change the items. That's just it. Then with dictionaries, they come with key value pairs. We'll talk in detail about them very well. They come in key value pairs. They are ordered because you can access the position of each item that is there. You can change them, you can remove them, you can change any item that is inside the dictionary, but they contain unique keys. You cannot have multiple keys. Like if you have, we'll talk more about them. If you have a particular item that's just there like that. So that's just what those four collection types are about. So we'll talk about each one and then we'll talk about methods that are associated with them. Remember yesterday when I was talking about strings, I mentioned that with each data type or collection type, there are some specific methods that work with just that type only. The same happens with all of these collection types. There are some methods that will work with lists that would not work in dictionaries, and there are some that are specific that works with both lists and tuples, and there are some that would only work on a list but would not work on a tuple. Do you get it? But would work on some of them here. So we've talked about lists before. We said a list is an ordered and changeable collection. You can change them and they allow duplicates like we mentioned earlier. And then they are created using square brackets. So let's assume that you're going to the market and you want to get you want to, you have a list of items that you want to get. So you have a list of fruits that you want to get. So you can just place them inside this square bracket. This square bracket indicates that this is actually a list. So you have apple, banana, and cherry. Do you get it? So you have apple, banana, and cherry. I can decide to add apple again because the beautiful thing about list is it allows duplicates. I don't know if it's a beautiful thing, but yeah, you get what I mean. So I can add apple again, and then I'll still be fine. Such that, let me comment all of this out so that we'll walk through them one by one. Such that if I do print fruits, I would have no problem with that. You see, we have apple, banana, cherry, apple still there like that, and they are ordered that way. So now when we are talking about order, that means we can easily access each item inside this particular list. I can say, okay, no, now remember when we're talking about strings, each character in the string is specific to like has a position. Like P has, when you're talking about Python, P has a particular position, T has a particular position, and like that's at the end. Now, when you talk about list, we are talking about each item that is inside that list would have a particular position, such that apple is in, remember, Python starts with 0. Apple is in position 0. This banana is in position 1. This cherry is in position 2. And this last apple is in position 3. Do you get it? So if I say fruit 0, the same way we did yesterday, fruit 0 will give you apple. Fruit minus 1, you remember negative indexing. Fruit minus 1 will give you apple, this last apple here. So let me remove this comment here and then run this. So you see, the first and last items are apple, so that's why we have that. And then you can do slicing the same way we did yesterday, where you can say you want from 0 all the way to 2, or you can do, since we're starting from the beginning, you can exclude this one all the way to 2. Do you get it? So that's what this slicing is about. So let me comment this out. Oh, let me make the comment here. So you did 0 to 2, and then you were able to like remove to get just apple and banana, because definitely it's not going to include 2. It's going to exclude 2. It's going to stop at 1. Do you get it? So that's how indexing and slicing work with lists. It's going to get the position of each item in the list. Do you get that? Are you with me? Hello?
Yeah, I'm with you. I'm with you.
So did you get that, or do you need me to explain something again?
I get it.
Okay, cool. So yeah. Now, what if you want to modify items in a list? Let's assume that you want to take change mango to um you want to change this banana. You know, the banana is the one that is in position 1. You want to change the part, but this banana to mango. So what you do is, this is where it gets tricky. Let me take this out so that you can focus on that part. Now, if I want to get what is in position 1, I will do fruits 1, right? To get what is in position 1. Now, the same thing comes with when I want to now change it. I want to change what is in position 1 to mango. You want to change banana to mango. What you just need to do is you reassign what is in position 1 to that thing that you want to change it to. So you're saying fruits 1 equals to mango. So that when you now print fruits again, let me print fruits the first time. So when I printed fruits the first time, the first item was banana. Now that I am printing fruits again, the first item is now mango because I have changed what is in position 1 to mango. Do you get that? Are you with me?
Yes, ma'am, I'm with you, ma'am. I get it.
Okay, cool. So that's just how it works. So if I want to change what is in position 2, what I just need to do is say fruits 2 is equals to pineapple. And then if I print fruit again, I would now have pineapple in position 2. That's just how you modify items in a list. Gaskin. Do you get it? So you can decide that you want to modify these two. Like let's say you want to change banana and cherry at the same time. You want to change banana and cherry at the same time. What you just need to do is, now you have mango and pineapple. Now, that's what is in the list now, in the fruits now. So I want to change it back to banana and cherry at this point. I don't want to delete what we've done here so far. What I will just do is, I'm saying I want to change what is in position 1 and 2. So how do I get position 1 and 2? To get position 1 and 2, normally you do fruits, if I want to get what is in position 1 and 2, I'll do fruits from 1 to 3. So it will not include 3. So I'll get mango and pineapple. That's what is in fruits at this moment. So if I want to get that now, what I'll do is, now I want to change mango and apple to, sorry, let me control Z. Yeah, let me leave that. So now I want to change mango and apple to banana and cherry. So what I will do is, that same fruits 1 to 3, I am just going to now be assigning it back. Since banana and cherry is not just a single thing, there are two things there, two different items. So I need to put them in that square bracket or even any kind of bracket. I could use that of a tuple too, but I need to like put it in a collection to know that it's just two items that I'm changing at the same time. If not, it's going to do something else. So I'll do banana, comma, cherry. So I'm changing 1 and 2 to that. Such that if I print fruits again, I would now have my banana and cherry back. Do you get it?
Ah,
Are you with me?
yes, ma'am.
Did you get what I just did?
Yeah.
Okay. All right. So that's just how to modify items in a list. Okay, so now there are some list methods. There are more than this, but I'll just be talking about these ones here. Now, the first one is append. Now, I know before we've just been changing, we've been modifying what is inside the list, we've been accessing what is inside the list. Now, let's assume that I want to add an item at the end. This one is at the end. But I want to add an item at the end of this list, but I do not want to like change anything in that particular list. What I will do is, I will just, okay, it's actually there. I will just append. I'll use fruit dot append. Remember how we write method, name of the variable dot the method name followed by how the method works. So I'll do fruit dot append orange. What this will do is it's going to attach orange to the end of this list such that if I print fruit, it's going to now have orange at the end. Okay, so let's print fruit at this point. So I'll have something that looks like this. Banana, apple, cherry, apple, orange. I have orange at the end. It's appended to the last part of the list, to the end of the list. Okay. Now, if there's a particular position that I want that particular item in, I would need to use a different method called insert. so that it will be in that particular position that I want it to be in. So let's assume that I want it to be in position 1. So that will shift the rest to, Apple was in position 1 before, and this was in position 2, 3. Now, if I put an item here, so that means the rest will shift by 1 position. So it's just like I'm saying, put this new item in this particular position. So for that, you use a different function method called insert. So I'm going to say fruit dot insert what do I want to insert? Pineapple in position 1. So and then I'll print fruit again. Okay. Oh, I think it's 1. See, 1 comma. This thing will come from in position 1 insert pineapple. Yeah, that's a mistake. So fruit dot insert 1 comma pineapple. What did it say?
No, I'm following up, man.
Okay, cool.
Yes.
So fruit dot insert in position 1 insert pineapple. So that's when you're saying I want it to be in a particular position instead of just the him. So whatever works for you, whatever you need at that particular moment determines which of these methods you will be using. So if I want to remove a particular item, I'll just use dot remove. So if I say fruit dot remove banana now, and I print fruits. I'm printing each one in this line so that you see how everything is working each time. So fruit dot remove banana. So you see it just removed banana from the list. There's another one dot pop, which will just remove the last item that you added to the list, which is fine too. Then there's fruit dot sort, which will sort the list in alphabet. If you have like a list that contains text, it will sort them alphabetically. If you have a list that contains, you can have a list that contains numbers too, and to sort them numerically from the smallest to the highest. Do you get it? For this thing, sort from highest to the lowest. Then for the reverse, to do the reverse of sort, which will be from highest to lowest or largest number to the lowest number. That's what reverse would do. To just reverse the list. Then len will just reverse. We give it the number of items in that list. If I want to know the number of items in this list, for instance, I need the number of items here. What I will just do in that case is say let me just print length of fruits, right? Length is actually a function. Sorry, print length of fruits. I need another closing bracket there. And yeah, it's giving me 5 because at this point I have 5 items inside that fruit variable. Do you get it? Are we together?
Yes, ma'am. I'm listening.
Okay, cool. So then we have tuples. They are tuples is like a list but immutable. Once created, it cannot be changed. So if you want to change, you can actually change it, but you have to convert it to a list first. Do you get it? You cannot change any item, and you cannot change any item that is already there. That's just it. If you want to change it, you have to convert to a list first. You can actually access items in that list, like using your indexing. So you can do color 0, color 1, color 2, you get it based on the number of items that you have there. You can do that. And remember, they are created with just normal brackets, rounded brackets. So you can access items. But when you want to change items, like the way we were doing with list the other time, you do something like color 0 or something to return an error. So let's try that. So if I should run this now, you see? Oh, If I run this, so you have a type error. Tuple object does not support item assignments. So you cannot change the item inside. So what you're attempting to do here is to change red to yellow. But it's when you're dealing with a tuple, you will not be able to do that. That's why you have this type error. Okay. So when do you now use tuple as compared to when you use list? When you want your data, not like you don't want to change anything in your data. So like when you're dealing with coordinates, or you don't want to change coordinates like latitude or longitude, you don't want to change your coordinates, or you have like a set number of days of the week. It goes from Monday all the way to Sunday, or whichever one you're starting with, and you don't want to change that. So whenever you do not want to change your data, then it is advisable that you use a tuple instead of a list. Do we get that?
Yes, ma'am.
Okay, cool. So then let's talk about sets. Now with sets, the set is another unordered collection that does not allow duplicates. So even if you have duplicates like this, and they are starting with curly brackets, you have curly braces here. So you have, now in this number, you created 1, 2, 3, 4, 5. Now, these ones, you cannot access the items. You cannot say you position one because they are unordered. Sometimes the 3 might come first or 2 might come first, although sometimes it just sorts it automatically. And then if you have these duplicates, if you have duplicates, you wrote 3 2 times. When you print numbers, it's just one of the 3s that will be showing up. So let's print numbers right now. You see, it's just one of the 3s that you have here that is showing up here. If you have 4 again, let's add another 4 here. Oh, I forgot my column. If you have another 4 and you run this, it's just one of it that will show up. It will not show up everything like that. Do you get it? So it's removed the duplicates automatically. So you can add numbers if you want to include, like you want to add another element to that particular list, to that particular set. What you just need to do is to say dot add, and it's going to add that particular item to the set, such that if I print numbers right now, you see it added 6 to numbers right now. Then you can remove a particular item or element in that particular set. So if we do numbers dot remove, to remove this one, it remove the 3 irrespective of how many 3s you have there. So and then if you print numbers, you see 3 is no longer there after printing numbers. So you can use the add method and remove method. You cannot do indexing with sets, like I mentioned, because they are unordered. Okay. Then there are some operations that you can perform with sets, like union, intersection, and difference. There are a lot of them. There are more. And remember, you can check them is by doing dir. Can do dir. You can do the same thing with lists to get the number of the functions that works with lists. I'll be the methods that work with lists. So yeah, you see, we have add, clear, copy, difference, all of those things. You have those ones. So now let's talk about union, intersection, and differences. If you remember, sets operations in mathematics when we started.
Mathematics.
Exactly.
Yeah.
So it's the same thing here. So if you have 2 unique sets and you want to see the union means that you are having everything between 2 sets. You have this set and this set. So if you do A union B, it's going to give you the unique values when the 2 are combined. You combine the 2, but it's going to give you the unique values there. So if I print A union B, so you can use A, then this standing stroke, yeah, as union, or you can do A dot union B. That works as well. That's why I wrote this here. So that would give you the combination of the unique values between these 2 sets. Then intersection. Intersection is the common things between those two sets. So like the common things here is just 3 and 4. So 3 and 4 appeared in both, right? And then the differences. Now difference will depend on the one you wrote first. If you say A minus B, so that means you are saying, okay, based on what appears in A but is not in B. So like 1 and 2 is in A, but it's not in B, so it's only going to focus on 1 and 2 here. So that's just what is there. So let's run that to see the results. So when you did A in B, you have the combination of both, the unique values of both. So you have 1, 2, 3, 4, 5, and 6. And then when you did intersection, it's just what is common between the two. And then difference is just depending on which one you write first. A minus B will give you what is only appearing in A but not in B, which is 1 and 2. And definitely they are going to show up like sets like this. Do you get it? All right, so we have dictionaries. They're also stored in curly braces, but the only difference between dictionaries, not just the, it's like a big difference. It's not the only difference. My bad. So but the thing is, they come in key value pairs. Yeah. So you have keys and then you have values. So the key is just what you would use to access the values inside the variable, inside that particular collection. Okay, so let's assume that you have a person like myself, and then I want to have like the whole thing, information about the person, like maybe name, and then I'm saying name is colon, but I'm not saying is equals to right now. I'm using colon to specify that the name is Zainab. Then followed by comma. So this is a key value pair. This is the key, name is the key, and the value associated with that key is Zainab. Then the next key value pair is age and 25. So age is the key and 25 is the value. Then the next key value pair is city and Lagos. So you see, after each key value pair, there is a comma after each one, just like you would have in a list. But this one we're talking about key value pairs together. So what is separating the key and the value is the colon. Just like you have it's a key, then value. So you can have a key and value pair. You can even have a list as the value here. You can have a list as the value. Yeah, you can do that. But here, I just want to make it simple so that you understand what is going on here. So we have name, Zainab, age, 25, city, Lagos. Now you can access the values in a particular dictionary based on the key, using the key. So I guess that I mentioned something that dictionary, you can access items in a dictionary, but using indexing, but a special type of indexing, because you are using the key as the index in this case. Let me put it that way. We are using the key as the index. So if you want to access a particular value like Zainab now, you have to make reference to the key to be able to get the value. Do you get it? So that's what is happening here. So the name of this variable, this dictionary, is person. Now, if I want to access Zainab, what I will do is say person, then I cannot use numerical index. I can only use text index, the key index here. So I want to access name. What is inside name, right? So I'm saying person, then make sure you're writing this in quotes, name, then square brackets, the normal way you would actually access a value. So if I run, let me comment this ones out. If I run this, you see, I have Zainab because I am trying to access Zainab here. Do you get it?
Yes, ma'am.
Okay, cool. So I'm trying to access Zainab. So if I want to access this age 25, what I will do is say print person age, and then I have my age there, 25. So you use the keys to access the values. That's just it. So now, if you want to add a new key value pair, yeah, a new key value pair, probably you want to say, okay, what's the occupation of this person? you say an engineer. So let me comment this part. And do the commenting. So you have person, occupation, engineer. You want to add this new key value pairs. Let me print person right now after this. Print person so that you see what is now there. So whenever you want to add a new key value pair, it's just like you're saying, I want to add this new key value pair. So you put the key inside. You remember how we were adding a new value, a new element to a particular position in a list. It's the same way. But yeah, instead of using the position like 0 or something, you're going to be using the key name, the name of the key as the index, where you now put, although I'm using the term index so that you understand what I'm trying to say here. Then the value would now be engineer. So the name of the dictionary followed by square brackets, and then inside the square brackets you have the key, then equals to, you assign the value, which is engineer, there, like that. So if I print person right now, you see I now have occupation in that particular dictionary. And if I want to see the occupation, which is engineer, I can do the normal this indexing, like this special indexing, like that. Do you get it?
Yes, ma'am.
Okay, cool. Are you saying yes, ma, because you get it, or because you just want me to move on?
I get it. I just need to go and read all this thing again. Like you have given us some things to read in W3 school. I just
Okay,
need to go and sit down and read.
okay. And then do some practice exercises. That's fine.
Yes.
Okay. So yeah, that's that. Then we have this updating existing value. So now let's assume that you decide that, okay, you want to change age to 26. So what you just need to do is the same way you added it, the same way you are adding a new key value pair is the same way you would be changing the existing value. So if I have something like this, person age equals to 26, it's just like I'm adding a new key value pair. But what this thing is actually doing, even with this occupation engineer, what is actually happening is, what it will do is it's going to go into the dictionary, check his occupation is a key in this dictionary. If it is not a key, then it has the key value pair. But like in the case of this age, age is already a key here. It looks for it, okay, it finds age there. Then it's going to now change whatever is in the age to this new value here. So that's just how it works. Do you get it? So it's going to follow
Yeah.
it. So it's the same way you are adding a new pair, is the same way you are changing whatever is existing in that particular key value. That's just how it works. Okay. So that's how you change values in a dictionary or add values in a dictionary. And then, okay. So there's looping through a dictionary, but I really do not want to go into too much details here, because when we get to loops, we'll do that in great details. But let me just give you a preview of what it does. It's just going to list the key value pairs, just like that. So there are some methods that works with a dictionary. Like if you want to see that, you can do dir, what is this called? Person, dir person, because that's the dictionary. So you see, you have a lot of functions there, not a lot, but you have clear to remove all items in the dictionary. You have copy to make a copy of the dictionary. You have from keys to get something from the keys of the dictionary. You have get, you have items, you have keys, and all of that. But let me just show you a few on how some of them works. So if you want to see, sorry, if you want to see how the key value pairs work, let me see, keys. So if you want to see like a list of all the keys that you have, I think it's going to show up as a tuple. So like person is like this, so you can do person dot keys, something like that. And then it's going to print all the keys name, age, city, occupation. That's all the keys. If you want to see all the values as a list, you can print all that. Person, dots. Okay, I think I should just print, not just output like that. Print. I'm taking advantage of Jupyter Notebook. That's why I'm not using print. So print person dots values, and I have all the values printed out like that. If I print dot items, it's going to give me the key value pairs as a tuple of a list, tuples for each key value pair inside a list. So I can do that item and do the dot items too. So I can do print person dot items. All this will be useful when you start looping and doing some advanced stuff with dictionaries. So you see you have a tuple, those items. So it's giving you the key value pairs as a tuple of a list of tuples. Yeah, a list of tuples. So that's just the major things about dictionaries. Okay? Okay.
Yes, ma'am. With you.
All right. All
Read
right.
the list.
What did you say?
No, I'm reading something here.
Oh, okay, okay, okay. So that's about that. So if you want to remove a particular item, you can do dot pop and all of those things and fine. All right. So there are some practice exercises here that you can go through, and then that's just it. So I think we've consumed a lot of things today. We talked about operators and we talked about collections. So I think we've covered some ground for this week. So I would be next week on Friday to be like majorly exercise day. We'll be doing a lot of exercises, and we'll be talking about most of the things that we've covered in this week. That's what we'll be doing majorly on Friday. So be prepared for that because you'll be doing some of the exercises live by yourself. So see you next week for week 2. So it is nice having you, and I think we've gone a long way. So I'll
Yes,
see
ma'am.
you next week too. So
All
if you
right.
have
Thank
any
you very much.
questions, feel free to drop them in the group, and then we'll continue from there. So yeah. All
All
right.
right, ma'am. Thank you.
You're welcome. All right. Take care. Bye.